My focus of research is both in human-robot interaction and natural language. I'm going to speak today about social intelligent robot in a shopping mall. Social robot is a combination of a robot and a social environment. Robot is just an intelligent machine which is autonomous and embodied. And what is social environment? Social environment is just the environment full of people. And the little plus here means interaction, social. Humanoid robot, it was designed and produced by SoftBank Robotics in Japan. And in addition to all the artificial intelligence that can be implemented into the robot, it also has the hardware that allows it to communicate with people, to be social, not just intelligent, but social. Another part of this challenge is the evaluation of such a dialogue, how to know that everything went well if we do not have a task in mind. For example, word overlap matrix means that, developers, we as developers, we usually have the data sets, annotated data sets of dialogues. And in those dialogues, people are speaking to either to a system or one to each other. And we have kind of ground truth, golden references that we can compare to and evaluate the new dialogue that robot is participating in. And these word overlap metrics actually, they do not work really well. First of all, they do not correlate with human judgment. The highest correlation that was achieved during the studies of how well these metrics work, it was 0.35, which is really very low. And another problem here is, as the previous speaker said, they have the same problem in product recommendation systems. It's the problem with the golden reference. What is a golden reference in the context of dialogue? What does it mean to have the proper, appropriate answer in a dialogue? Imagine a user is asking a robot, have you read the latest Murakami novel? And we have a golden reference in our data set which says that the proper answer for this question would be, no, I don't think I have read it, what is it about? And imagine that the robot have generated during the dialogue other utterances, a couple of them. One is, for example, yes, it wasn't my favorite, but I still liked it. And another one is the one about the sheep. So both are appropriate, proper answers, but they do not overlap at all with the golden reference. So the blue matrix, the word overlap score would be just 0. In this case, which is not good, of course. It is much better to use the reference-less matrix, which means exactly what it says. It does not use reference. And what it detects, it tries to predict what would be the evaluation of a human for a specific dialogue answer. And for this, we can use either simpler classification algorithms like SVM or random forest, or a more sophisticated deep learning methods like recurrent neural nets. We have made a study with recurrent neural networks, and it proved to be quite a good method which achieves the correlation with human judgments of about 0.8, which is quite an increase comparing to 0.38. The highest. The main idea here is you need to encode the generated utterance of the robot into the system output encoder, and you also need to encode the meaning representation of what the robot is going to say. And then you combine those into fully connected layers and get the output of this recurrent neural net as some kind of score, which is a predicted human score. So in this case, it is, for example, 6 out of 6, which means it's a good answer. So what I want you to take home from my presentation is, I believe that AI and machines should be transparent in their intentions, in what they want to achieve in the specific time moment.